Good morning, everybody. It's Mr. Motohon here. And I would like to, for those of you that choose to watch this video, congratulations. This is our last lecture of the school year. Definitely an interesting year, to say the least. But, we did our best to get this far, and you should be proud of yourself for reaching this point. So our last topic has to do with solving log equations. And I'm going to cover a few examples so that you can do your final Delta Math assignment and start getting ready for your final. Before I actually start I just want to remind you of the properties that we've been talking about for about 2 weeks now. So I have all of the properties listed right here. So remember, we have a multiplication rule that says multiplication inside of a log becomes addition. We also have a division rule that says division becomes subtraction. And we also have a power rule which says any power moves to the front. And one thing that I want to remind you of is also remember that these properties work two ways. So if you start with multiplication, it becomes addition. If you start with addition of two logs, it becomes multiplication inside one log, etc., etc. And another thing I want to remind you of before we get started is the conversion, the way that we convert between logarithms and exponentials. So for example, if we have log base b of a, another way to say that exact same thing, get that exact same idea across, is to say, oh, sorry, I should have written it like this, equals, let me do it like this, equals x. So we can say it like this. Remember the loop-de-loop trick. So we take this as our base, this is our power, this is our answer. So it would be b to the x power equals a. So just keep that in mind because that's going to be super useful in these examples. So there's pretty much two types that I want to cover. One is pretty straightforward, shouldn't take you too long, and then the second one uses the same properties, but it also brings in quadratics. So we're going to have to factor, which is the one that uses the x and the box. So I'll remind you how that works in a second. Okay. All right. Problem number 1. So it says log base 3 of 7x minus log base 3 of 2 equals 5. So first thing I want you to notice is we are in a position where we have two separate logs, and in between those two logs we have a minus sign. So you probably remember from a week or two ago, I taught you how to do this thing called condensing logarithms. And this is exactly why we learned it. Because in this scenario, it's really difficult to work with two separate logs being subtracted. But if we take this whole expression right here and turn it into one logarithm, then we can easily apply this conversion property right here, and then it'll be much easier to solve. So let me go back real quick. So we have subtraction between two logs. So that is telling me the property where we have log of a minus log of b. Another way to say that is just log of a over b. So remember, we said division inside of a log turns into subtraction between two logs. So another way to say this, log base 3 of 7x minus log base 3 of 2, would be, so we're going to condense it into just one log now, and that's going to become division. So 7x on top, 2 on the bottom, and then 5. So again, notice how the subtraction turned this into division inside of one log. Okay, perfect. So we did the condensed version, and now we're going to actually I guess you can think of it like a knot. You're going to untie the knot. You're going to undo the logarithm so that you get access to what's all in there. So So the way that we undo a logarithm is we take exactly the rule that we set up above. We take the base. So remember, this is the base. We do the loop-de-loop. This would be the power. And this would be the answer. So if I was converting this logarithm, I would write this as 3 to the 5th power equals 7x over 2. And now notice that we no longer even have a logarithm at all. This is pretty much turned into an exponential equation, and it's a lot, I guess, friendlier because there's not really many letters or less letters, and we can work with this. So a great place to start would be maybe simplifying this numerical expression. So 3 times 3 times 3 times 3 times 3. I believe that is 9 times 9, 81. 81 times 3, so 243 equals 7x over 2. Remember, whenever we have a number alone, we can always write that over 1. And now we're in a position to cross multiply. So we can go that way and that way. So this will be 7x times 1 is equal to 243 times 2. And this will be 7x is equal to 486 divided by 7. And I don't think that's going to go any further. Let me see if it's a nice number. 486 divided by 7. 486 divided by 7. No, it's not a nice number. Yeah. So that would be my answer. Definitely not a pretty answer, I know, but it is the answer. So 486 divided by 7. So that would be the answer to the first one. Okay, then you also, here's another example of the same type. Again, notice that we start with 2 logarithms, and we could condense that into 1 log. Now, before we do the condensed version, I also want to point out to you that there is another property here that we didn't see in the first one. There's a number in front. If we go to this example, there was no number in front in either of these logs, but here there is. So before we do the condensed version, I just want to do a quick reverse power rule. So remember, the power rule says if we have a number in the front, like here, that's the same as that number being the exponent. So we brought it up, and so we can say, another way to say this log is log base 2 of 5x plus log base 2 of 3 to the 4th power. And if we want it to be even a little bit more simple, we could break down 3 to the 4th. So 3 times 3 times 3 times 3 will be 81. So log base 2 of 81. And this is all equal to 5. This is all equal to 5. Okay, so now we're in the perfect place to do a condensed version of this log. So what does the rule say if we have addition between 2 logs? If we have addition between 2 logs, that is the same as multiplication inside of 1 log. So I'm going to go back here. I'm going to apply that property. And so I'm going to say this is the same as log base 2 of 5x times 81, which admittedly is probably going to be a pretty large value, but that's fine. Okay, so notice that we took the addition of both of these numbers and we turned it into multiplication. So now this is log base 2 of 405x. And this is where, now that we're down to 1 log, so notice that we're down to 1 log, that's how we know that we can convert it back to an exponential. So how does that process work? I'm going to take the base, oops, sorry, that's not a good color. I'm going to take the base of this logarithm, raise it to the power, and then make it equal to the answer. So this will be 2 to the 5th power equals 405x. If I simplify 2 to the 5th power, that would be 2 times 2 times 2 times 2 times 2, which I believe is 32. And this is 405x. Divide by 405, divide by 405, and that, I don't think that can be reduced anymore. 2, 16, no, I'm going to say that's it. So that would be the answer to my equation. Again, not the prettiest answer, but it is an answer. And that is pretty much how to solve these type 1 questions.